would say that two fractions are equivalent if their values are the same. So for example, if I had a fraction of 2/4, well, an equivalent fraction would be 1/2. And there's lots of other equivalent fractions, maybe 50 over 100. Now each of those fractions, their values are the same. They're just broken up into different pieces. 2/4, that's half. 1/2 is half. 50 over 100 is half. We would say the one in the middle, this 1/2, we would say that's an equivalent expression or equivalent fraction, but it's also simplified. I can't reduce that down anymore. So what we're going to do is look at a process of how we can find a simplified equivalent fraction. So the process similar to this. Let's look at an example like 6/14. One way to do this is let's rewrite 6 and 14 into its prime factorizations. If I were to factor 6 all the way down to its primes, that would be 2 times a 3. 14, if I were to factor tree that down, that would become a 2 times a 7. From there, I could look to see if there's any factors on top that are common in the bottom. And if there are, I could factor those out, and then what I'm left with is an equivalent expression, equivalent fraction. The value hasn't changed. It is simply simplified. All right, let's look at another idea. Let's look at 15/75. Well, that can factor down to 1 and 15, 3 and 5, 75 factors down to lots of things. So let's factor that one down to 3 and 5. That's its prime factorizations. 75 factors down, I don't know. So let's do a factor tree. That goes down to 3 and 25. 3 stops. 25 factors down to 5 and 5. So 75's prime factorizations would be 3 times 5 times 5. What factors on the top and the bottom cancel out? The 3's factor out and the 5's factor out. And I'm left with a 5 in the denominator, but I have nothing in the numerator. What do I put up there? Is it 0? Is there 0/5 left? No, be real careful of that. What is left is a 1. There's an understood 1 in the numerator in that particular expression. Because 15/75 has a value, it's not 0. So an expression can't be 0/5 as one way. So there really is a placeholder of a 1/5 in the numerator. All right, 2 more examples. 25/11. It's an improper fraction. And it's all right to have improper fractions. I know when you're reducing problems, you might reduce it down to an improper fraction and you feel the urge to change it into a mixed number. I'm fine with either one. I want you to be able to do both, but the context of the problem will probably give you enough information to know, do I need to convert this to a mixed number, or is leaving it an improper fraction fine? All right, 25 factors down to a 5 times a 5. 11 factors down to a 1 times 11. 11 is prime. 25 is composite. Composite means you can factor them down. Prime means you cannot factor them down. Any common factors in the numerator and the denominator? No. So its simplified expression is itself 25/11. Now let's look at 11/33. What can we do with that? Well, 11 does not factor down. It itself is prime. So it's 1 times 11. And 33, that factors down to 3 times 11. And you can see a common factor there as 11 and 11 equals 1/3. And so that's one process and one way to think about how we can reduce or simplify a fraction into its equivalent simplified form. One other thing that I want to kind of maybe show you if I got room here is another idea of how that's happening. These factoring, these canceling outs. We'll use this one as an example right here. So let's go back and write 1 times 11 over 3 times 11. Well, this is similar to the idea of 1 over 3 times 11 over 11. What is 11ths? Well, that's really the value of 1. In fact, it's kind of a clever version of 1. Any number over itself produces a value of 1. And what do we remember about any number multiplied by a 1? We remember that that number remains with the same value. So 1/3 times a 1 remains 1/3. So I'm canceling out a number on the top with a number on the bottom through factoring. I'm factoring out a common factor on the numerator and denominator. And I'm also doing that because those common factors really create a value of 1. And multiplying anything by 1, its value remains intact. So however you want to think about those, when you simplify, is fine. I just want you to practice these so you can get the habit and get the hang of it fairly well.